In this video, we will implement our facade using test-driven development. So that's it for preamble. Let's get started. Alright, so the first thing we'll do is we will create a class declaration for the implementation of our facade. A lot of big words there. So I'm just going to right-click on the data package, go to new Kotlin file or class, and I'm going to type calculator impl. So if you haven't already kind of figured it out by now, impl stands for an implementation, so a concrete thing of an interface. So of course we have the prefix I for interfaces, and we have the suffix impl for implementations of an interface. If you've ever wondered what that word means, to implement something, it means to build it, to make a real thing. So anyways, we're going to type class, oh, not there, class calculator impl. And so this is of course going to extend our iCalculator interface, which is our facade. And also, I know from problem domain analysis and building the domain layer that this thing is also going to require an evaluator and a validator. So we're going to say val validator, iValidator, and then we'll also add in the evaluator. Alright, then I'm also going to implement the members here, but we won't actually implement them because now we're going to create a test class and carry on from there. So now I'm down in the test package. I'm going to right click, go to Kotlin file or class, and this is going to be calculator impl test. So in this class, we are of course going to do a similar situation to what we had before. So the first thing we'll do is we will create the fake data and fake classes necessary for testing the class. So the first thing I want to do is create the fakes here. So we're going to go private val validator equals validator fake impl. And actually, let's just control D that. Then we'll have our evaluator. And we're actually, let's add in the fake name there, just for legibility. And then we will also have a fake version of our logic class, which will basically be what we'll be calling the callbacks to. And what we'll have that thing do is it will actually sort of record the result which our calculator implementation gives to it. And of course we will create a late init var for our calculator. Calculator impl. So of course we want the real one since that's what we're actually testing today, but we won't actually instantiate it yet. So let's go ahead and build out these different fakes. So the first one I'll make is the validator fake impl. So as usual, make that, and then we'll make the evaluator fake impl, and then we will make the calculator logic fake impl. And there we go. So let's start with the validator. So we're actually going to do something slightly different here. We're just going to build these fakes as classes just below our calculator impl test. That's perfectly legal in Kotlin, and it's just going to save us from having to make a bunch more files when we don't really need to. All of this stuff is going to get stripped out of the production build anyways, so it doesn't really make a big difference. So let's get busy building those classes. So the first one we'll make is the validator fake, and that's going to extend iValidator, of course. We'll implement the members here. Just the one validate expression. So what we're going to do is, again, we're going to have some variables, internal var succeed, and that will default to true, and internal val called, which will also be a boolean, which will default to false. So what we'll do is In the validate expression, if this function gets invoked, then we will set called to true, and we will return succeed. So we'll return whatever we want it to return, essentially. And that's all we need to do for the validator fake, since it just returns a simple Boolean. Then we have our evaluator fake. And implement that. Oops, that's not what I wanted to do. Maybe it was. Okay, so for the evaluator, similar situation. I'm actually just going to copy and paste these two, so I just want to know if it was called or not, and if it should return successful or not. But we need to return something a little bit different here. So we'll still say called equals true if it gets called. Now what we'll do is we'll say return if, so this is a particular kind of if statement which will return whatever is kind of the final expression in both the if and the else blocks. I believe I covered that in the course, but just in case. So if succeed, then we want to say result wrapper.build. And so what we're going to do is we want to return a valid answer, and also we want to be working with some kind of valid expression for the most part. So, well, in the success case. So what we're going to do next is we're actually going to make some test data here, and I want that to be visible to all of the different classes in this particular file. So we're going to use some internal const vals. Why is it internal? You could even make it private, but internal is just a nice general safe visibility. It is only visible within this module. But like we're not really too concerned about hiding just random test data in this particular case. Anyways, internal const val valid expression, which will be a string, and that'll just be 2 plus 2. I'll hit Control D. This will be valid answer, and 2 plus 2 is 4. And we'll also make an invalid expression just for fun, and that'll be 2 plus b. Technically, we can't even... Actually, let's not do that. Let's make it 2 plus plus plus, which shouldn't evaluate to anything proper. The user won't even be able to type b in the application, so that makes a little bit more sense. All right, so we have our test data. Let's head back down to our evaluate expression function here, and so we'll return valid answer. Oops, that's not what I wanted to do. There we go. And then we'll say else. We of course want to return some kind of error, so we'll say throw exception, and not too important what the exception is, just use the basic exception. So that looks good there. And then we also need to set up our calculator logic fake impl. So we're going to call this, what did I call it up here? Okay, that's the problem. This needs to be calculator. This needs to be actually the interface. Calculator UI.logic is what we want. Actually, I'm not sure if that's... We don't actually need to have it extend the interface. My mistake there. It's not actually going to know which class the function comes from, so we just need to make sure it implements the proper function. So we'll just say calculator logic fake impl, and then we'll create that class. It will extend the interface here. Calculator UI.logic, implement that. Alright, so we don't really care about the handle view event function because that's not really going to get used here. By the way, if you are using these fakes in other areas, you might actually want to put them in different files. Anyways, so we're going to have a Boolean var handle result called, which is what we really care about. And that'll default to false. And then we're also going to have a result property here, or member. So what we're going to do with this one is we're going to default it to null. It'll be of type exception string, and that'll be a nullable. And so what we can do here is we'll know if the calculator impl actually did its job and gave this function or this class a result through the handle result function. And then we can check on that later in our assertion statements. So what we'll do here is we'll say this dot result equals result, and then handle result called equals true. So that's it for our fakes and our test data, and now we can get started writing out the actual tests. Okay, so we only have two tests to write here, just a success case and a failure case, a pretty simple implementation. So what we'll do is we'll say fun on evaluate valid expression. And of course we'll write a Java doc comment here. So we're going to say, so what's going to happen when we give this thing an expression? So the first thing we want to do is give the expression to validator. In the success case, it will return true, which means it's valid. Next, give expression to evaluator. And if it returns a string, it's successful. So now we know what to expect. And then finally, return the result to the callback. So we'll see how that works in a moment. Of course, we need to actually create our calculator. So we say calc equals calculator impl, and we'll give it our validator and our evaluator. Oh, that needs to be a fake actually. There we go. And so we need to call the unit that we'll be testing. So we'll say calc.evaluate expression. So we'll give it the valid expression here. And then what we'll do is we will say logic fake, and then we'll do the double colon again to refer to the particular function. Handle result called, oh no, that's not correct, my bad. Handle result. There we go. Okay. So it's showing up red because we haven't implemented it. Next thing we'll do is we'll create our assertions. All right, so next thing, because I decided to make our test fakes here as vals, we're just going to want to reset the everything to its initial state. So what that basically means is we want to type logic fake dot result equals null. So we'll just be explicit about that. If we were creating these things each time, obviously we wouldn't really need to do that, but that's just to make sure everything will work properly. We're going to say val result equals logic fake dot result. So if everything works properly here, then the result will get updated to what it's supposed to return, or what it's supposed to be. And then we'll make an assertion statement on the result. So, if result is result wrapper dot success, then we will just make a quick assertion statement. We'll say assert equals, which is another JUnit function here. Let's just import that. Assert equals, so we want to say result dot value, and we want to say valid answer. We don't even really care so much about what the actual state here is. We're more concerned about the behavior. Is it returning a success case in this particular example? And then for the other case, we're going to say else assert true false. So what does this mean here? It basically just means, oops, that's not what I... So what does this mean here? It basically just means fail the test if this thing is not a success case. So what we'll do is we're not going to be able to actually run this test yet properly because we haven't implemented it, but we're just going to run it to make sure everything's well formed to follow the proper TDD procedure. Alright, so we have a compilation error which says that suspend function evaluate expression should be called only from a coroutine or another suspend function. So how we're going to fix that, of course, is we want to say run blocking up here. So if you are wondering how to run tests on suspend functions, what you'll want to do is you want to use this run blocking coroutine builder. There is actually a test library. I think the coroutine builders like run blocking test, which also works, but typically you can get away with just making whatever test case which needs to call a suspend function as a run blocking coroutine builder. That should fix that particular error. Let's see what happens next. Okay, so that's what we want to see here. An operation is not implemented, so now we can jump into our class that we wish to implement, and we can implement it. So I'm not even going to look at my code on the side here. Let's just do this logically. So let's just follow our steps up here. Give the expression to the validator. If true, then it's a valid expression. And then we give it to the evaluator, and then we just return that result to the callback. So hopping into our calculator here, we're going to say if validator dot validate expression, so we give it exp. We're going to say if that's the case, then we're going to type callback dot invoke. And what is it going to invoke? It's going to invoke the result, which comes from evaluator dot evaluate expression exp, just like so. Otherwise, what we need to do, alright, so let's see if we can get that particular test to work. Okay, so that test is passing. Let's move on to the next one. So I'm just going to copy and paste all of this. And what we'll do is we want to give the expression to the validator, and I want it to return false for invalid this time. And we can skip that step entirely, and we'll just say return result to the callback. So this will be on evaluate invalid expression. And what we'll do here is we're going to say to the validator, validatorFake.succeed equals false. And we'll make sure we give it an invalid expression. Again, I don't actually really care too much about the data in this particular case, but might as well do that for consistency's sake. And then we want to make sure that error is called. So what we can do here is we can just say assert true in this particular case, otherwise assert true false, and that should be everything we need to do. Okay, so let's go ahead and run that test again. Alright, and then we can jump in and implement it. So if that fails, we want to say else callback dot invoke result wrapper. Here, let me just get that formatted a little better. Result wrapper dot build throw exception, and we'll see if that fixes it. And there we have it, all tests passing. So that's all we need to do for the calculator facade implementation, and the next thing we'll do is we will work on the validator and the evaluator.